Hi girls. So today we are going to do the very last part of integration, which is called the average value of a function. Just yeah, just checking if you can see that. Yeah. Okay. So once again, calculus has so many applications. So when we were in doing differential calculus, we saw that you may not just be asked to differentiate or find dy dx or find the derivative of. For differential calculus, you could be asked to find the maximum point or the minimum point or maximize some sort of situation, like a company wants to maximize its profits. You could also be given the type, it could be a graph kind of situation, and it could say the slope of the tangent. That also means that you're dealing with differentiation as well. Um, and there's lots of other applications such as finding the speed, finding rates of change, etc. So what we found though when we've done integration is that uh, I suppose the biggest application of this is finding the areas underneath curves. Let's say when we look at graphs, finding exact ones. The trapezoidal rule gets us so far, but these do it exact. So this is a bit similar to that. But what this is in really simple terms, because what I'm going to do is I'm going to upload a link in Teams whereby you can have a look at a video that explains the formula I'm going to show you. It goes into much more detail, but in the very simplest terms, what we're going to be finding here is the average height of a function, or of a curve, of a line, of a function, on a graph. Okay, so the average height, and it is kind of what it says on the tin. Average is adding up, let's say, the numbers and adding up two numbers, dividing by two, or whatever it is you're looking at. But here you're not just dealing with lines, you're dealing with curves as well. So that's why we bring in the integration. It does it for all types of shapes, curves, lines. Maybe what I'll do is change that to function, any kind of function. Okay. So what that means in other terms as well is that if you're looking at the average height, it means we're dealing kind of with the y values, because that's what the height of, let's say, a function would be its y values, and the average height of them. Okay, so I'm just going to throw the formula up so you can see it. And what the formula for this is 1 over b minus a, and that's the only kind of bit that's extra here. And you're going to integrate between b and a. So we've dealt with this before, when we were doing any of the other stuff. These are just going to be numbers. It's going to be the interval in the x-axis. And yeah, fx dx. Okay, so what I am going to do is do two questions out so you can see how we're going to do this. Okay, these, by the way, are on pages 89 to 93. So they start, but I don't know if you can see, can't see that, sorry. So I'm going to put kind of the page number of where the questions are. So I'm going to be going to page 93. That's where I'm going to be getting the questions from. Question I'm thinking to myself is this in the formula book? I'm not sure. I'll have to get back to you on that. But I mean, the only thing here is we're integrating this function between these two values, and then it's 1 over the bigger minus the smaller value. That's what that is, okay? Right, so I am going to do, first on page 93, I'm going to do question 4 to start. So question 4 says, find the average value of a function, x squared plus 4, for where x is between -2 and 3. Okay, so just write this down, question 4. I won't write the whole question out. You'll have it in front on page 93. So they gave fx is equal to x squared plus 4 And the interval you're interested in is between 3 and -2. So for this one, they're not giving me a graph, and sometimes they will. But if you wanted to picture this, what's it going to look like? It's going to be x squared plus 4. I'll just do a tiny sketch here, but I'll rub it out so I have space. X squared looks like that. It'll be x squared plus 4 like this, right? It would look something like that. And it's going to be between, let's say, 2 points there, okay? But I'm going to take that off so it doesn't get in the way of my function. But sometimes they do give you a graph so you can actually see what you're doing. Okay, so as we said, we're going to write this down. You're going to put 1 over. Now it's b minus a, so this is like your b, the bigger of the two values, and this is like your a. Just point b a. So this is going to be 1 over 3 minus -2. And then I'm going to be integrating between 3 and -2. And I'm going to integrate the function x squared plus 4. Okay? And you can put a dx beside it. Okay, by the way, I'm filthy, as you can see, because obviously it's to do with Rhonda. She got out the back after it had rained and came into the house a while ago, and the whole place is destroyed, including a couch that's not old. So she's in the bad books, even though she doesn't even know what she's done wrong. So that's why you're probably thinking, oh, miss, what the hell is all over you? That's what this is, because that just happened a while ago, and I will have to shower in a little while. Okay, so back to this. Let's work this out. This is going to be 1 over 3 minus -2, which will be 1 over 3 plus 2, because minus by minus makes a plus. So let me just go straight ahead and call that 1 over 5 if you're cool with that. Which I'd say you are. Not liking how that looks. And I'm not the neatest person, but sometimes things are just too messy. 1 over 5. Okay. Now, integrate this. Nice integral here. X squared will become, so I'm going to put a little line, it'll become x cubed over 3. Again, why? It's when I get down to the bottom of this, I find it hard to write on it because I'm hunched over. X cubed over 3 plus 4x, and that is between 3 and -2. Okay, sorry that they're a bit close there. What I might do is just move that -2 up there. Okay, so this is what we're dealing with here. Now what we're going to do is we're going to sub in 3 and -2 to everywhere where there's an x. Now see that 1/5? I'm going to leave that out in front, so it's going to be like this. 1/5. So the first one's going to be 3 cubed over 3 plus 4 by 3. And then minus 1/5 -2 cubed over 3 plus 4 by -2. Okay, so let me just double check I've done everything okay there. Yeah, so then I sub 3 into that one and -2 into that one. Okay, calculator time. So if we now work these out, this is, I'll leave the 1/5 in front, but let's put this all into the calculator. We'll get 3 cubed divided by 3 is 9. 9 plus your 12 is 21. Double check that because I always double check my calculations. So it's so easy to put something in wrong. Yeah, that's good. And then 1/5. This is going to be -8 divided by 3, because -2 cubed is -8. And then -8 here, which is -32 over 3. Okay, remember it's always good to show as much workings as you can, because it just means then that you get as much marks as you can. Right, so it's 21 divided by 5 is just 21 over 5. And then this is going to become a plus because minus by a minus, and it's 1/5 So again, I'm just going to use the calculator to do this. 1/5 by 32 over 3, which is 32 over 15. And now add on with your fraction button 21 over 5 to that. And you get 19 over 3, which I'm just going to SD, and that's the same as 6.3 recurring, or 6 1/3. Okay, so what that means is that is going to be the average value of the function, or the average height of this function between these two intervals. What I'm going to do is I'm going to stop this because it's 10 minutes long, and I'm going to go do another example now, and I'm going to do a trigonometric one because I know that we need a bit of practice on them. Okay,